Welcome students. In this video we are going to see the number of atoms or average number of atoms per unit cell for the simple cubic structure, face centered cubic structure, the body centered cubic structure and for hexagonal closed pack structure. Let us see. We are going to see the average number of atoms per unit cell, or these are also known as the effective number of atoms per unit cell. Okay, so definitely we are going to see it for simple cubic, face centered, body centered cubic and one hexagonal. So how to calculate the average number of atoms? Okay, suppose if I take the first crystal structure, that is for the simple cubic, Now first of all, see, this is the cube. We will create the formula for that, how to get the value of this average number of atoms. So see here, so for this cube we are having the 8 corners, 1, 2, 3, 4, 5, 6, 7, 8. So at each corner we are having these 8 atoms. Okay, so there are 8 corner atoms and these corner atoms definitely shared by 4 cells जो उसके पीछे है और 4 cells जो इसके आगे है. So see here, so if you look this, so suppose this one atom gets shared by how many cells? So this is 1, this is 2, 1, 2, this is 3 and 4th. Okay, so this is, we can have at back side and from the front side also these 4, 1, 2, 3 and 4. So definitely, so 8 corner atoms is going to shared by the 8 cells, isn't it? So we can have the corner atoms in NC. If I have the number of corner atoms, so here number of corner atoms कितने यहाँ पे 8 and how many cells that it going to share? The 8 cells. So 8 cells share this 1/8 of each atom, isn't it? So NC is the number of corner atoms. 8 corner atoms, it is going to shared by the 8 cells, isn't it? So for every cell 1/8 of the entire 1/8 like that 8. So 1/8 shared by the 8. Okay. Then we are having the NF, that is number of face centered atoms. Of course we are seeing the simple cubic, तो simple cubic में कोई face पे कोई atom नहीं है, only 8 corner पे कितने atom है? 8 atoms है. Okay, so here see, in simple cubic structure we are not having any face atom which is present on the face of this cube, but whenever this atom is present on the face, suppose if I take, for example I am taking, because we are going to see all the cubic structure, that is simple के बाद FCC आएगा, BCC आएगा. So wherever there is this face atom, so it gets shared by the 2 adjacent cells. Okay, this face atom, suppose ये ऐसा है, so this is the plane and you are having this atom on face. So adjacent cell में दो एडजेसेंट सेल, एक ये और एक ऊपर वाला. सो दिस फेस आइटम इज गोइंग टू शेयर्ड बाय टू एडजेसेंट सेल्स. ये एक सेल है, उसके ऊपर एक सेल होगी, ये आधा आधा क्या करेगा, शेयर करेगा. प्लीज रिमेंबर, सो जनरली फेस आइटम इज शेयर्ड बाय द टू एडजेसेंट सेल. सो टू एडजेसेंट सेल कितना शेयर करेगी, आधा आधा, सो मिला के एक होगा. सो टू एडजेसेंट सेल विल शेयर हाफ ऑफ दिस आइटम. आधा नीचे वाला सेल, आधा ऊपर वाला सेल. सो प्लीज रिमेंबर, whenever there are the face items, you should get the number of face centered atoms like this, that is 2 into 1 by 2. We are talking about cubic crystal structure. And of course last one is Ni, which is number of inside items, number of inside, or you can have number of body centered atoms, which only shared by, which atom is only shared by the one cell. अगर ये क्यूब के अंदर एक कोई बॉडी सेंटर पे कोई एटम है तो वो खाली कौन शेयर करेगा, ये यही सेल, ये यही एक ही क्यूब से शेयर करेगा, उसके अगल बगल के कोई शेयर करने वाले है नहीं. ओके, फॉर एग्जांपल बॉडी सेंटर्ड क्यूबिक में क्या होता है, दिस ओनली वन एटम इज एज द बॉडी एंड at the 8 corners we are having the 8 atoms. Okay, so this is the body centered cubic. So understood how to get these values Nc, Nf and Ni. So this addition of all these items will give us the average number of atoms. Okay, so we can make the formula like this. So average number of atoms, the average number of atoms for the cubic crystal structure we can calculate as Nc divided by 8, standardized formula कर रहा हूँ मैं, plus Nf divided by 2, क्योंकि 8 कॉर्नर के आइटम क्या शेयर करेगा, 8 सेल शेयर करेगी, 1 बाइट. देन दो एडजेसेंट सेल क्या शेयर करेगी, फेस का आइटम, एंड Ni will be shared by only one or single unit cell. Okay, so only this is Ni. So this is the formula for cubic. Okay, so we have taken here the simple cubic first. So we know that in simple cubic there are 8 atoms at the corner of this cube. 1, 2, 3, 4, 5, 6, 7, and this is 8. No face centered atom, no body centered atom. So these are going to be zeros. So 8 corner. So how many corner number of atom? Number of atoms are the corners. 8 divided by 8, which is equal to 1. Okay. So simple cubic में average number of atoms कितने हैं? 1 है. Now take the example of face centered cubic. We know this is the FCC, face centered cubic. See the diagram. So 8 corner पे 8 है ही. क्यूब के फेस कितने होते हैं, हाउ मेनी फेसेस, द क्यूब हैज 6 फेसेस. सो ऑल ऑन दिस फेसेस यू आर गोइंग टू हैव दिस all the faces we are having this face centered atom. Okay, so face centered atom कितने सेल शेयर करती है, 2 सेल्स. ओके, लाइक दिस, आधा ऊपर का और आधा नीचे का. ओके, ये फेस पे एटम. ओके, फेस पे. सो दिस वन एटम विल बी शेयर्ड बाय 2 एडजेसेंट सेल्स. एडजेसेंट मतलब ये नीचे की और एक ऊपर की सेल. सो इफ यू राइट द फॉर्मूला, Nc divided by 8 plus Nf divided by 2 plus Ni. अब यहाँ पे कॉर्नर पे कितने हैं, 8 है ही, 8 कॉर्नर पे है, 8 डिवाइडेड बाय 8 प्लस फेस पे कितने हैं, क्यूब के फेस कितने, 6 फेस पे 6, सो प्लस 6/2. फेस सेंटर में हाउ मेनी नंबर ऑफ एटम्स आर इनसाइड दिस सेल, नो एनी बॉडी सेंटर, सो 0. सो टेल मी what are the average number of atoms in FCC? So this is 1 plus 2, that is equal to, sorry, 1 plus 3, it is equal to 4. Okay, so FCC is having 4 average number of atoms in its unit cell. Okay, so average number of atom कितने हैं इसके अंदर, और effective number of atoms in the FCC are 4. Like that we can calculate for BCC also. So third will be for body centered cubic. So tell me in BCC क्यूब है, 8 कॉर्नर पे 8, वन टू थ्री फोर 5 6 7 8. Okay, and one at the center, बॉडी के सेंटर में एक. सो कितने हो गए टोटल, सो कॉर्नर पे 8, Ni 1, सो नो एनी एटम ऑन द फेस, सो यहाँ पे NF कितना है, 0. वी नो द फॉर्मूला फॉर एवरेज नंबर ऑफ एटम, कितने हैं, NC डिवाइडेड बाय 8 प्लस NF डिवाइडेड बाय 2 प्लस इंटीरियर में कोई है क्या, है एक एटम है, सो 8 डिवाइडेड बाय 8 प्लस 0 प्लस 1, सो 8/8 1 प्लस 1. सो द एवरेज नंबर ऑफ एटम्स फॉर द BCC यूनिट सेल वी गॉट इट एज दी 2. ओके, सो ये हो गया अपने क्यूबिक स्ट्रक्चर में सिंपल क्यूबिक का 1, फेस सेंटर के 4, BCC के 2, एवरेज नंबर ऑफ एटम्स. सो नाउ वी विल आल्सो कैलकुलेट फॉर द हेक्सागोनल क्लोज पैक स्ट्रक्चर, क्लोज पैक HCP. सो हेक्सागोनल में क्या होगा, सो the corner, there are how many corner atoms will be there, 12 corner atoms. I will draw the diagram here for the hexagonal closed pack structure. So see here, in hexagonal closed pack structure we are having these corner atoms 1 2 3 4 5 6 7, this is 8 9 10 11 12. सो कॉर्नर पे कितने हैं, 12. ऑन द फेस वी आर हैविंग 2, 1 at the top 1 at the bottom, that is 12 13 14. And the interior of this cell we are having 3. Okay, so this is actually the hexagonal pack structure. Okay, so see here 12 corner atoms are going to shared by, so how many cells, the 6 cells. Okay, and this face atom is going to shared by 2 adjacent cells, and the interior atoms, how many there, in one unit cell of this hexagonal closed pack we are having 3 interior atoms, of course. And see, this line is going to pass through the centroid of these 3 like this. Okay, and this is nothing but our height C, and here A is equal to B. This is the distance between the atoms is AA. Okay, anywhere it is A. So here A is equal to B, but it is not equal to C, so we have to have here relation between this C by A ratio. C by A ratio is very important for the calculation of atomic packing factor. Definitely we will going to see that. So here these 12 corner atoms are going to shared by the 6 cells, then shared by how many? 6 cells. Then 2 face atoms. We know face atoms are shared by 2 adjacent, shared by 2 adjacent cells, and there is the interior will be shared by only 1 unit cell, and interior is shared by 1 or single unit cell. Then tell me, what will be the formula? What will be the formula for the average number of atom for the hexagonal close packed structure? The average number of atom will be equal to what? This ENC by 6, isn't it? Plus NF by 2 plus NI. Okay, so यहाँ क्यूबिक में क्या था? Instead of 6 there were 8 corner atoms, isn't it? यहाँ पे कितने हैं? 8 सेल ने वो 8 कॉर्नर एटम शेयर किए थे. यहाँ पे 12 कितने जन में शेयर होगा? 6 सेल्स में क्या होगा? होंगे, शेयर होंगे. ओके, सो लेट अस कैलकुलेट. सो वी नो दैट NC विल बी 12 कॉर्नर एटम्स, सो 12 डिवाइडेड बाय 6 प्लस फेस कितने हैं? 1 2, सो 2 डिवाइडेड बाय 2 प्लस इंटीरियर में कितने हैं? 1 2 3 इंटीरियर, सो 2 plus 1 plus 3, so totally how much? So 6, please remember. So effective number of atoms for the HCP structure कितने हैं? 6. Okay, so please dear students, in this video what we learn? We learn to calculate the average number of atoms per unit cell, or the effective number of atoms per unit cell. Definitely सिंपल क्यूबिक के लिए कितने होते हैं? 1 फेस सेंटर्ड क्यूबिक, मैच द पेयर्स के लिए बहुत बार आता है. 4 बॉडी सेंटर्ड क्यूबिक, 2, इजंट इट? और हेक्सागोनल क्लोज पैक स्ट्रक्चर के लिए कितने? HCP के लिए कितने होते हैं? 6 होते हैं. ओके, प्लीज यू कैन डायरेक्टली कीप इट इन माइंड, you can get direct answers. Thank you.